Hello everyone. So welcome back to my YouTube channel Cam 3MD Mind Catalyst, and we are continuing structure of atom. So in the last lecture we discussed the present model of the atom, the orbital concept. We saw the 3D models, how atoms look alike. Now we are coming to the history of the atom, a very simple to the complex structure. So history starts with, as I already summarized, Dalton's. So Dalton's atomic theory. There are main postulates of Dalton's atomic theory are the most important is atom is indivisible. Each and every postulate of Dalton was failed. Atom is indivisible. But we know now atom contains subatomic particles, proton, electron, and neutron. So according to Dalton, the smallest unit is indivisible. Then the second, atoms of one element are similar, but we know कि अभी हम डिस्कस करेंगे आइसोटोप्स. Isotopes of elements, atoms of same element but having some different properties, and atoms of different elements are different according to Dalton. So isotopes, isobars, they will fail the postulates of Dalton atomic theory. So this is about Dalton's atomic theory, and then comes the scientist J.J. Thomson. J.J. Thomson, he discovered electron. So first we are going to discovery of electron. Electron was discovered in a vacuum tube. Electron was discovered in a vacuum tube. Anode, cathode, they are connected to a battery, a high voltage battery. And then Thomson reduced the pressure inside by a vacuum. He created almost pressure very low, almost zero. And on one side of the glass tube, there was coating of zinc sulfide. Zinc sulfide creates a fluorescent effect. This is important for the question, which layer? So zinc sulfide layers which creates fluorescent effect. So when he switched on this high voltage battery, what he noticed? He noticed a shining effect on the zinc sulfide layer, and he noticed the rays. He named the rays as cathode rays, as they travel from cathode to anode. If there were rays traveling from negative terminal to positive terminal, cathode to anode. Since these rays travel from negative to positive, so cathode rays are negatively charged. They contains negative charge, and these negatively charged particles are named as negatively charged particles named as कि फिर इनको नाम दे दिया इलेक्ट्रॉन का वाई पार्टिकल कि if we keep any object in the path of this ray, so they cathode rays cast shadow. The cathode rays cast shadow. The cathode rays shows deflection in electric field and magnetic field. इलेक्ट्रिक फील्ड में अगर इसको रखते थे तो दीज कैथोड रेज, अगर हम बाहर से एक और एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाई कर दे तो दीज कैथोड रेज दे मूव्स टुवर्ड्स द पॉजिटिव चार्ज. It shows deflection in electric field as well as magnetic field. These are the few properties of cathode rays, and they led to the discovery of the subatomic particle electron. और इस इलेक्ट्रॉन के आने के बाद बस फिर पूरी केमिस्ट्री डिजाइन होने लगती है. The whole chemistry runs on the loss or gain of electron, the metallic character, the non-metallic character, the atom size, everything depends on this electron. This Thomson discovery gave a revolution to the structure of atom. और ये सब 1900 की बातें हैं. These all models जितने भी हम पढ़ रहे हैं they are generally of 19th century. This is all about cathode rays which discovered electron. But similarly, with same experiment, after few years there was discovery of proton. तो एक पहले हम वो भी देख लेते. Then we are going to discovery of proton. Proton was discovered by Goldstein. कि जैसे वो थॉमसन ने एक्सपेरिमेंट किया कैथोड रे, वैसे ही गोल्डस्टीन का एक्सपेरिमेंट होता है एनोड रे एक्सपेरिमेंट. तो एनोड कैथोड बस थोड़े बहुत चेंजेस है, बाकी सब सिमिलर है. कि दी कैथोड वाज परफोरेटेड, देयर वर सम गैप्स, एंड अगेन ZnS लेयर on the cathode side, and there was ray traveling from anode, the positive terminal, to the negative terminal. From the positive terminal to the anode. So these rays were named as anode. They travel from anode to cathode. So they are positively charged. The similar experiment done by Goldstein that led to discovery of proton positive charge. And then there was, and this is the Thomson model. According to the Thomson model, the body of the atom contains positive charge. This model is like India में watermelon, and or we call it as plum cake model, जिसमें dry fruits they are randomly distributed. Similarly, electrons they are distributed randomly, and outside there are the boundary is positively charged. This is the Thomson model. The body is positively charged and electrons are randomly distributed. बट उस टाइम थॉमसन के टाइम पे प्रोटॉन्स डिस्कवर नहीं हुए थे, बस ही जस्ट मेंशन्ड पॉजिटिवली चार्ज्ड. And then discovery of neutron. Then there is discovery of neutrons. A neutron was discovered. A neutron, the neutral particles, they beryllium and helium. Helium particles are bombarded on beryllium. Beryllium atomic number 4, mass number 9. Helium atomic number 2, and they converted to carbon 6C12. Now 4 plus 2 atomic number is conserved, but the mass number 9 plus 4 13, and carbon mass is 12. So there is one particle, a neutral particle whose mass is 1 and charge is 0. A neutral particle that was named as neutron. It was discovered by Chadwick. It was discovered by Chadwick. He bombarded helium particles, the alpha particles, on the beryllium, and that led to the discovery of neutron. So proton, electron, and neutron. So who discovered proton? Proton was discovered by Thomson, proton by Goldstein, electron by Thomson, and neutron by Chadwick. The mass, the protons, they have mass of 1.6 into 10 raised to power minus 27, 1.67 into 10 raised to power minus 27 in kg, or 1.67 into 10 की power minus 24 in grams. And the charge 1.6 into 10 raised to power minus 19 coulombs. So electrons are positively charged, electrons are negatively charged, and neutrons, they are neutral. The mass of electron is 9.11 into 10 raised to power minus 31 kg, or 9.11 into 10 raised to power minus 28 grams. And neutron, they have mass same as protons. The mass of neutron is same as proton. So these are the subatomic particles discovered: proton, electron, and neutrons. Then, before moving further, first we are discussing some terms related to proton, electron, and neutrons. एक तो इनकी quantity of proton, electron, and neutron. Proton, electron, neutron, तो एटम और आयन, चाहे एटम हो चाहे आयन हो, number of protons is always equal to atomic number. बस पूरी केमिस्ट्री में मेन है इलेक्ट्रॉन्स. इलेक्ट्रॉन्स अगर एटम है तो नंबर ऑफ इलेक्ट्रॉन्स इज इक्वल टू नंबर ऑफ प्रोटॉन्स. दैट इज व्हाई एटम्स आर न्यूट्रल. बट इन आयंस, the ions are formed by loss of electron known as cations. Ions are formed by gain of electrons known as anions. इलेक्ट्रॉन ही लूज हो सकते हैं, इलेक्ट्रॉन ही गेन हो सकते हैं. इन द नॉर्मल सिंपल एटम्स, नॉट ऑफ द न्यूक्लियर केमिस्ट्री, एटम्स अगर इलेक्ट्रॉन लूज करता है तो जैसे सोडियम कैटायन, सोडियम लूजेस 1 इलेक्ट्रॉन टू फॉर्म Na+1. तो अगर सोडियम एटम की बात करें तो इट हैज 11 प्रोटॉन एंड 11 इलेक्ट्रॉन. बट अगर सोडियम कैटायन की बात करें तो प्रोटॉन्स तो सेम रहेंगे, ओनली इलेक्ट्रॉन इज लेस. एंड क्लोरीन atomic number 17, 17 proton, 17 electron in neutral state. But chlorine ion is formed as an ion by gain of 1 electron. So chlorine contains 17 proton and 18 electron. 17 proton and 18 electron. So these, how we calculate protons, electrons and neutrons, they are equal to mass minus proton. कि जो एटम का सारा मास है that is concentrated in the nucleus. तो अभी हम उस पर बाद में आएंगे. So mass is equal to proton plus neutron. So mass is equal to proton plus न्यूट्रॉन. तो न्यूट्रॉन डिस्कवरी तो हो गई, बस अभी न्यूक्लियस वी आर गोइंग टू डिस्कस इन रदरफोर्ड मॉडल. उससे पहले फर्स्ट वी आर डिस्कसिंग दिस टर्म्स, देन वी आर गोइंग ऑन टू रदरफोर्ड मॉडल. तो क्लोरीन का मास एज वी नो 23. सो क्लोरीन कंटेन्स न्यूट्रॉन्स 23 minus 11, 12 neutrons. So now there are some questions related to this. Some questions. So first you note down, make the notes, and then there are NCERT question 42, 43, 44. That are based on the quantity of proton, electron and neutrons. So this is the NCERT question based on the concept the an ion with mass number. This is an ion with mass number 37 possesses 1 unit of negative charge, and if ion contains 11.1% more neutrons than the electrons, find the symbol of the ion. कि we have to find the atomic number. The atomic number will give the symbol of the ion, and atomic number is equal to number of protons. This is an ion with 1 unit of negative charge, and we will use this statement. It contains 11.1% more neutron देन इलेक्ट्रॉन्स। तो जो देन के बाद जिसके कंपैरेटिवली लिखा है, आई एम टेकिंग इट एज एक्स। लेट इलेक्ट्रॉन्स इज इक्वल टू एक्स। तो न्यूट्रॉन्स कि जितने इलेक्ट्रॉन्स हैं उससे भी 11.1% ज्यादा है। 11.1% ऑफ क्वांटिटी ऑफ इलेक्ट्रॉन्स एक्स। न्यूट्रॉन्स इज इक्वल टू x plus 11.1 by 100x, x plus 0.111x, so 1.111x। ये तो हो गए न्यूट्रॉन्स इन टर्म्स ऑफ x। अब प्रोटॉन्स, क्योंकि हमें क्वेश्चन में मास गिवन है एंड मास इज इक्वल टू प्रोटॉन्स प्लस न्यूट्रॉन्स, इसलिए वी हैव टू कन्वर्ट प्रोटॉन इन टर्म्स ऑफ x। तो दिस इज एन आयन which has one negative charge, means one electron is extra, one electron is gained। तो इसका मतलब प्रोटॉन से एक इलेक्ट्रॉन एक्स्ट्रा है, तो इसका मतलब प्रोटॉन्स आर लेस, कि प्रोटॉन्स आर वन लेस देन इलेक्ट्रॉन। प्रोटॉन इज इक्वल टू x minus 1। This is the equation for proton. So mass 37, proton x minus 1, and electrons or neutrons 1.111x। So from here we will get the value of x। 37 is equal to, ये प्लस 1 इधर आ जाएगा, -1 एंड x प्लस, तो 2.111x। So 36 is equal to 2.111x। So x is equal to 36 over 2.111। So from here we will get electrons, और जितने भी इलेक्ट्रॉन्स आएंगे उससे एक माइनस करके we will get protons, and that will become the symbol। That will become the symbol of the atom। So understand how we have solved this question। This will come as x is 36 divided by 2.11, so it will come approx 17 point something or approx 18। If this is 18, then protons is equal to x minus 1, it will be 17। So this element is chlorine। This element is chlorine, atomic number 17, mass number 37, and chlorine gains 1 electron। So this is how we solve the questions based on proton, electron and neutron, and similarly 42 and 44. These two questions are also based on this। So this is proton, electron, neutron, and now there are few more terms: isotopes, isobars, isotones, and isoelectrons। So isotopes, atoms, elements having same atomic number same atomic number but different mass number. Same atomic number but different mass number are known as isotopes. So like same atomic number, hydrogen, hydrogen, hydrogen. In nature, there are three type of hydrogen atoms with mass number 1, mass number 2, mass number 3. This we have already discussed in chapter 1 also isotopes, and almost hydrogen exists in the form of first isotope with mass number only, also known as protium. The second is deuterium and the third is tritium. Similar isotopes, chlorine, the most famous, 1717 mass 35 mass 37. And we also discussed in chapter 1 the average isotopic mass. Isobars, species having same mass number but different atomic number. Same mass number but different atomic number. एटॉमिक नंबर सेम है, जैसे कैल्शियम एंड आर्गन की मास आर सेम फॉर बोथ बट दे आर एटम्स ऑफ डिफरेंट एलिमेंट्स. Atoms of different elements can also be similar. They are with same mass number. This is example of isotopes, isobars. Similarly, carbon and nitrogen. One isotope of carbon having mass number 14 is isobar with nitrogen. Then the third term, isotones. Isotones means species having same number of neutrons. Neutrons कैसे निकलते हैं? अभी बताया, मास माइनस प्रोटॉन्स. तो सोडियम मैग्नीशियम, सोडियम 11 एटॉमिक नंबर, मास 23, मैग्नीशियम 12 मास 24. ये एटम के सिंबल में नीचे एटॉमिक नंबर, ऊपर मास नंबर. मास नंबर को ए से लिखते हैं, एटॉमिक नंबर को जी या जेड से लिखा जाता है. तो न्यूट्रॉन्स mass minus proton 23 minus 11, magnesium 24 minus 12, so both have 12 neutrons, isotones. And isoelectrons या isoelectronic, species having same number of electrons. दो एलिमेंट्स में इलेक्ट्रॉन कैसे सेम हो सकते हैं? जैसे नियॉन having 10 electrons, और सोडियम जब एक इलेक्ट्रॉन लूज कर दे तो 11 में से एक इलेक्ट्रॉन गया, सो इट इज ऑल्सो 10 इलेक्ट्रॉन. मैग्नीशियम 2 इलेक्ट्रॉन लूज कर दे, सो इट इज ऑल्सो 10 इलेक्ट्रॉन. एल्यूमिनियम 3 इलेक्ट्रॉन लूज कर दे, सो इट ऑल्सो बिकम 10 इलेक्ट्रॉन. फ्लोरीन 1 इलेक्ट्रॉन गेन कर ले, ऑक्सीजन 2 इलेक्ट्रॉन गेन कर ले, नाइट्रोजन है 7, it gains 3 electrons, so all are isoelectronic. This is the isoelectronic series. So isotope, isobar, isotones and isoelectrons. Now coming on to the Rutherford model. First Rutherford discovered nucleus. Discovery of nucleus. What is nucleus? How it got discovered? So for that What Rutherford did? Again, the alpha particles, the charged alpha particles, which are helium. The helium with two electron lost. So these are alpha particles, and he bombarded alpha particles on a very thin gold foil. So there were major three conclusions, major 3 points, and then their conclusions. The points, the postulates, the properties. What Rutherford noticed, most of the alpha particles passed without any deflection. Most of the alpha particles passed without any deflection. Most of the alpha particles passed without any. Second, very few passed at an angle or got deflection. Very few got deflection. And the third, very rare, 1 out of 20,000 rays deflected at an angle of 180 degree. They followed the same path. They retraced the path. So these are the major points and then their conclusion. Now we are coming on to the conclusion. Most of the alpha particles passed without any deflection. What conclusion does it give? Most of the space, these are the conclusion points. Most of the space of atom is empty. Then very rare passed at an angle, the alpha particles are positively charged. So it means there is some positive charge in the center of atom. And very rare, this shows some of the rays, most of the mass is highly concentrated. This is the most important point, is highly concentrated in the center of atom in a very small space, and he named it as nucleus. This led to discovery of the nucleus. एटम के सेंटर में एक बहुत छोटा सा मास है जिसमें प्रोटॉन्स और न्यूट्रॉन्स बंद हैं और इलेक्ट्रॉन्स उसके आसपास घूम रहे हैं, and most of the space of atom is empty. This is Rutherford discovery of nucleus. This is Rutherford's model. Most of the space of atom is empty. In the center of the atom, there is a highly mass concentrated unit. and he named it as nucleus. कि जो रेस इस न्यूक्लियस से टकराती थी, दे फॉलोड द सेम पाथ. जो न्यूक्लियस के पास, दे वर डिफ्लेक्टेड and most of the rays passed without any deflection. This led to discovery of nucleus, a very important model, and this model was corrected further. Make the notes. There is one limitation of Rutherford model. There is one limitation of Rutherford model, and that will be corrected by Bohr's. बस इसकी limitation कि if a charged particle is moving in a circular motion, then its acceleration goes on decreasing, and finally it will collide, it will burst into the nucleus. It will burst into the nucleus. तो बुक्स में ऐसे डायग्राम होता है कि इलेक्ट्रॉन, when it is in the circular motion, it will keep losing its energy, it will keep losing its acceleration, and that will lead to the collision of electron into the nucleus. So this is Rutherford model. बस इस Rutherford model के बाद मेन Bohr's model, and that is a lengthy topic. How Bohr discovered shells, how Bohr discovered energy levels. So this is the transition that will be there from Rutherford to Bohr's model, and that we will discuss in the next lecture. So this is for today's, this is all about the past, and that we will continue. So thank you so much. Keep listening, keep subscribing my channel, Chem 3D Mind Catalyst.